We will be looking at unsigned binary multiplication. Unsigned binary simply means the numbers are always positive. There are two methods for this multiplication: the paper approach and the hardware approach. The paper approach consists of a multiplicand, a multiplier, and a partial product. It is important to note that n represents the multiplicand and q the multiplier. Also that the multiplicand is multiplied by each bit in the multiplier, and the results are known as partial products. When the multiplier bit is 0, the partial product is 0. On the other hand, when the multiplier bit is 1, the partial product is the same as the multiplicand. Each time a partial product is calculated, there is a shift to the left in the paper approach. The final answer is the sum of all the partial products. Here is a paper approach example. We will be multiplying 12 by 12. In this first cycle, the multiplier bit, which is on the line, is 0. Hence, the partial product result at the bottom is also 0. In the second cycle, the multiplier bit is also 0. Hence, the same result. But notice the new partial product has shifted to the left. In cycle 3, notice the multiplier bit is now a 1. And the partial product result is the same as the multiplicand, and notice that this has also shifted to the left. In cycle 4, the same thing is repeated as in cycle 3. When all the multiplier bits have been used, you sum the partial products and get the final result. 12 by 12 is 144, and this is the number represented in binary. Now the hardware approach. In addition to M and Q, in the hardware approach, A represents the accumulator and C the carry. The accumulator stores the sum of its previous value and the newly calculated partial product as they are calculated. When the multiplier bit or least significant bit for the multiplier is 0, only a shift operation is executed. When the multiplier bit or least significant bit is a 1, and add and shift operations are performed. Note that the add is done first. The shift function simply works by taking the least significant bit from the leftmost column, i.e. the carry column, and moving it to the most significant bit of the column to the right. This is done for all columns except the multiplicand. The multiplicand always remains the same. The final result is the values of A and Q combined in the last cycle. The length of the final answer can be estimated by combining the length of Q and M. Here's a hardware approach example. We will be multiplying 12 by 12. Note the initial values of C, A, Q, and M. In the first cycle, the least significant bit of Q is 0. Hence, only the shift operation is performed. Notice the arrows and the colored zeros. These indicate from where and to the zeros are moving. The least significant bit from the carry, which is 0, goes to the most significant bit of A. This causes a shift which in turn makes the least significant bit of A go to the most significant bits of Q, and the least significant bit of Q is then discarded. Please note that the shift operation shifts all the bits to the right and not necessarily replaces a particular bit with another. In the second cycle, the same is repeated as in the first cycle. Take note of the arrows and the underlying zeros. In the third cycle, the least significant bit of Q is 1. Hence, the partial product is 1, 1, 0, 0, 1, 1, 0, 0, and 0 when summed is 1, 1, 0, 0. Hence, that is the value stored in the accumulator when the add operation is executed. Next comes the shift function. It follows the same rules that were executed in cycles 1 and 2. In the fourth cycle, the least significant bit of Q is 1 again. Hence, the add operation is executed. The new partial product is 1, 1, 0, 0, is 1, 1, 0, 0. This is summed with the current accumulated value of 0, 1, 1, 0. The result is a 5-bit number. 10010. Since the accumulator can only store 4 bits, the 4 least significant bits is stored in the accumulator, and the extra 1 bit is stored in the carry. The shift operation is then executed as normal. The 1 in the carry goes to the most significant bit in the accumulator, and the least significant bit in the accumulator moves to the most significant bit in queue. The least significant bit in queue is then discarded. Since all the multiplier bits have been used, this is the final cycle. The final answer is A and Q combined, which gives 10010000. Here are some questions you can attempt to test your understanding on unsigned binary. Thank you.